Hi everybody, this is Flash001 USA. It's August 24th, 2013. It's about 11:30 in the afternoon here. This will be a first handful of how-to videos of how I constructed my gasifier. And where I want to start is with the heart of this, and this is going to be where the fire cone and everything is housed. What you're looking at here is a rim from a trailer. It's brand new actually, and I purchased this from Northern Tools. What I'm going to do right now is zoom in on it and let you see everything on it off the label here, so you know exactly what to get. Okay, now to modify this thing, this is what I'm going to do. I'm going to cut this thing in half, okay, but it's got to be done correctly. If not, you won't be able to use it. This piece right here, this is going to become the bottom. This is where the output of the gas is. This piece here will be cut off like a soup bowl, and it's going to be flipped around and welded to the top of it. This way you have a nice deep place to put your fire cone in. And I'll do that using one of these guys right here, okay? I don't have a safety cover on it because I need to be able to get in this thing a certain way to be able to cut into it. And because of that, you definitely want to be wearing some good leather gloves. And I can't stress this enough, safety has got to be your top priority when you're doing this, okay? Because you're cutting this stuff free-handed, for those of you that don't have a machine shop at your disposal. And that includes safety goggles, something to protect your breathing, and even something to protect your hearing. So what I'm going to do right now is explain exactly what I'm going to do as far as the cuts go, and then we're going to get started. Okay, inside this thing right here, there's a piece of steel that separates both of these guys here, this piece here from here, and we want to leave that piece of steel on the bottom to the piece where my hand's at right here. And the way we're going to do this is we're going to cut it right here. You'll see where my finger's at. There's a weld seam for the piece of steel plate in there. We're going to cut on the bottom of the steel plate. We're just going to go all the way around it and score it. And we'll do that 2 or 3 times until this piece falls off. And then what we're going to be left with is this piece right here with this piece fully intact inside of it. And that's 9/10 of it right there. Then we're going to turn back around and we're going to cut this lip off of here. That'll be the second cut we do. Once we do that, we're pretty much on the way home to making a vessel that's going to support the fire cone. And there's no use drawing any kind of lines or anything so that you can see where to cut, because it's going to be self-explanatory when you're doing this, and you won't have any problems with it. It'll all come together as you're doing it. So on that note, let's get started. And before I do that, I'm going to break out a tape measure and let you guys see the inner diameters and measurements on this thing. So take a standby here while I go grab the tape measure. Okay, the inner diameter of this guy is about 7 3/4 inch. Okay, that's on the wide open part right here. A little bit less than there, but it really don't make a difference. The outer diameter on this guy is almost 9 inches. It's like, I don't know, just minus about 1/8 or so from being 9 inches. But for some of you guys out there that were asking about that, I hope that answers the question for you. And the same with this side here too, okay? Same thing. It's just deeper. So on that note, I'm going to put the camera up on the tripod, and we're going to go ahead and videotape this while I'm doing it. I will edit this out so that you don't have to sit here and watch me cut all this up, but at least you'll see what I'm doing and understand what you need to do if you decide to use these materials. Let's get started. Something else too, you'll need one cutting blade to do this with, and you also need a grinding blade to knock off any of the sharp edges so that you don't wind up cutting yourself or creating havoc. So just to be aware of that, you need a couple different mixtures of blades. Alright, that's the first cut, and I'll give you another close-up of this by hand because I don't know if I'm centered to the camera right now, but there you go. This is the bottom part of it. Notice how clean it cut. I mean, I'm saying this thing's really cut nice. If you take your time with this, you can get good clean cuts. And this is the soup bowl I was talking about. Now this will go right on top like this, okay, when the time comes. What I need to do now, I'm going to do the same thing. I'm going to score this all the way around and remove this lid because I want to be able to get to this with the welder. Alright guys, got this thing separated from it, and this start making more sense now. Now I've got to grind out and get everything prepped up or it won't fit in there, but you'll see how this welds on here. Hopefully you can see this. Alright, the first thing to do is knock off all these sharp edges because this stuff's like razors all the way around it. So let's do that. Okay, that's pretty much it right there. That's knocked off everything and there's nothing that's going to cut me. So the next thing I'm going to do is I'm going to go back around and I'm going to pause the camera out because this is something that's really a video waster, but I'm going to go back and I'm going to knock all the enamel off this guy right here. And I've got to do the same thing with this guy here. You see how he's fitting in there now? So I knocked all that crud off of it like a damn glove, okay? So what I got to do is knock off the enamel right here, and I got to do the same thing on the bottom of him. This will allow me to put these together and get a real weld on these things. So, I'm going to pause back out. Alright guys, I've got everything ground down and prepped up and it's ready to weld together. This is the bottom section here. As you see, I've got it ground down to the steel. I got the enamel removed off of it. I've also knocked off and buffed off all the sharp edges so I don't have to be concerned about cutting myself while I'm working with this. This is the top section. I've prepped it up also, and you can see they're married together like this. And of course they'll be welded to keep them permanent. Now, on this top section here, I also had to go around and grind the steel down on the lip here because remember, this has got to weld to the wood hopper. That's how it's held in place. Now there's one more thing that I have to do before I actually start to weld this thing together, and that is I've got to make this thing where it can accept chains to be able to hang the grate with. And the way I'm going to do that is, get one of these out of the bag here. I've got these guys right here, okay, and I'm going to drill 3 holes. So one goes here, here, and here. They'll be 120 degrees offset with each other. Now to do this, I took a shortcut because to me it's simpler like this, and I am computer literate. So what I did is I used a program that allowed me to measure this and draw me a circle that's the same diameter. And basically what I can do in that circle in the computer is I can rotate it by degrees. And so what I did is I drew me a line on the circle and locked it in place to the circle. I rotated it, did the same thing, and I did it one more time until I had 3 lines that were 120 degrees offset with each other. Then I just cut the circle out, and now all I have to do is do this number right here. And I'm going to pull the camera off, and hopefully I won't mess anything up doing this. Okay. What I'm going to do now is go back with a magic marker, and I'll tag it here, here, and on this side right here, and drill holes for these guys right here, okay? And I'll go ahead and bolt them in, and then I'll tack weld them on the inside so that he never comes loose. Once I do that, I'm ready to actually weld this thing together, and then we're ready to move on to the fire cone. So I'm going to take a pause and move to the next step. Alright guys, I'm getting ready to drill the holes for the hooks that are going to support the chains for the grate. But before I do that, I will drill pilot holes with a small bit, okay? And before I do that, I'm going to use a punch and I'm going to go around this thing where I've got the 3 markings. I'm going to do this number right here. Reason being, I don't want the bit dancing around on me. Got one more. That'll be a good place here to do it. My punch is nothing but a mason's nail or a concrete nail, because this stuff is like extremely hard steel, and you can grind these things to a nice hard point, real sticky hard point on a grinder, and if you lose it, you're not out any money. So these things are really good for using for punches. Alright, let's get started with the drilling. I'm going to pause out here. In the excitement of making the video, there was something that I forgot to mention, and that is where you drill the 3 holes for your hooks. They're going to have your chains on them. You got to get inside here and take the grinder and knock off the enamel here also, so you can get a positive tack weld. The same applies for your bolts right here. I actually went around the sides of the bolts and gently brushed them with the grinder to knock off any galvanization, and I also went to the bottom of this rim right here and knocked off all the enamel where they sat in here. This way I can go around it and tack weld it, so don't forget to do that. I almost forgot to bring this up in the video here. When you put the hooks in, make sure they're facing straight up and down like this, all the way around on it, just so that you know that. This way when you hang the chains on them, they can hang straight down. So just wanted to interject this into the video. Alright guys, this is the last piece of the puzzle, and this is the last extension piece that goes on the bottom of him. I just got through pulling this off of my gasifier that you see in the videos. Notice that it's a straight piece of pipe. Originally, I built one with the inverted bell, so the inverted bell went on like this right here, okay? And I didn't like the way it operated, didn't like the way it felt. It caused me issues and I wasn't happy with it. I was cracking tar with it, but it just caused me more problems that I don't want to bring in discussion as far as this video goes. So I wound up going with straight pipe, or that is, I rolled me a round piece of steel on this guy. And let me tell you, when I did that, all my troubles went away, and this thing works great. As a matter of fact, I'm going to show you something. There's not a speck of tar on this. That's nothing but soot, okay? And as you can see, it's a straight pipe, so it's almost falls in the lines of a FEMA, but it doesn't, okay? It's a bastardized design, and a lot of people that's been joking with me calling it the Gasifier, I guess after my YouTube username, but I found out this actually worked much better. Hold on one second, I'm going to grab some. Alright, this is my ash grate here, and normally I'm set at maybe about, I don't know, maybe an inch above it or something, give or take a little bit. And this thing will actually, as it's emptying down, all the biochar will fill up and hang on the sides of this thing, and as you shake it, it falls over and makes room for more of it, okay? But when I was using this inverted bell, for some reason, too much material was falling through the bottom of it, and I wasn't holding a good ember bed. Now, I could have ran it closer. I could have ran it much closer and stopped that, but I like the design that I'm working with now. To me, it's more stable. The videos that I'm doing a proof of it, the gas that I'm getting out of it, and you guys have actually seen the flares that I'm getting off of it. When I'm running the thing on startup with non-filtered, I've got Halloween orange, which is an absolute indication of cracked tar being burnt, and I've got baby blue propane-like gas after the filters. So that's why I'm going with this design right here. Now that I'm going to get off that subject, I'm going to go back to this guy right here. He's got to be placed on the bottom like this, and what I'm going to do is I'm going to be taking these guys here and putting them in. I'm going to be tacking them in place, but I want to make sure everything's lined up. So the reason I'm bolting him on for now is so that I can weld these guys on, and once they're welded into place, I can pull this thing off and I know that it's absolutely lined up. So with that note right there, I'm going to pause the video out and take it to the next step. Alright, I've got the extension piece mounted on here, that you get a look at it. The reason my hand is so black, like I said a second ago, this actually came off of the gasifier that you see in the videos. Now, let's flip it. You can see inside of it. Before I take this piece here and marry them on here, the first thing I'm going to do is I'm going to go inside here with the welder, and I'm going to tack weld all these guys here to make sure nothing comes unscrewed or busts loose. The same thing with the hooks for the chains. And once that's done, I'll go ahead and double check my work, and I'll unscrew this and make sure he comes on and goes off with ease. Okay, the last thing you want to be doing is fighting something if you have to disassemble it and do any kind of maintenance on it. But there it is. And while I'm at it, this extension piece here extends out 3 inches. Okay, So the cone sits on top of this guy right here, and actually my whole cone, the whole cone ember bed and everything, is right at 9 inches deep. That's much deeper than what you find on your everyday gasifier. But now you're not burning 9 inches of actual embers on it. You got to keep in mind that, I don't know, about the first 2, 3, 4 inches, 3 inches, something like that, is going to be your red hot ember bed, and of course as it goes deeper, and by the time it starts coming out of this end right here, it's already biochar, okay? So it's already turned to biochar, because you don't have, people have the misconception that the whole thing inside there is just a blaze, and it's not. You have your reaction, that's right at your ember bed, and of course everything above that ember bed is where your gas is being made, because you got the pyrolysis happening from the heat, which is baking that stuff, that it pulls in, and then as it goes down, it starts to physically lose heat, and comes out the other end as biochar, which is then captured inside of this guy right here, okay? So on that note, I'm going to pause back out, and we're going to take it to the next level, which is getting this thing prepped up, getting it welded together, and then we'll go to the fire cone. Alright guys, I've got the rim welded together. Now this is the vessel that's going to house the fire cone, okay? But it's completed, and it's ready for the next step, and what I'm going to show you right now is the cone, and in a moment I'll explain how I made this thing. So let's take a look at it. Now it's not completed, I still got some welding I got to do, but I'll do that here in a couple minutes. Notice it kind of looks like a flower pot. So I got the cone, and then I got a piece that's not coned on top of it. I got a ring on top of it, which is what I got to go weld on it next. Now, this guy here is 5 inches in diameter on the top, and he cones down to 3 inches. And it's a total of 6 inches height with the ring and the cone included. And then we have another 3-inch extension on this thing, so you can see I've got a really deep cone on this. And I think this also attributes to why I'm getting good clean gas and stable burns. At least that's one factor of it. Now I want to show you something here. I pulled this out because when I started building my FEMA originally, I had 2 of these made because I was building one for a buddy, and I actually used a lot of the ideas that Joshua Burks put out there. And once again, I'd like to say thank you to him for helping me in the very beginning, because he did give me a lot of pointers, and I actually did like he did on his. I put an ignition port on the side of it. I think he came down or came up 4 inches from the bottom of his output of it right here, and that's where he put his. I did the same thing, so I copied his pretty much, okay? Now, let's take a look at this, and I'm going to show you something here. This is the ring off mine. You can see how much more real estate I have on this guy here. So this guy is probably good for at least no minimum than a 15 horsepower motor. It'll handle it. It should handle it with no problems. I'm running a 5 horsepower off of it, and I'm just getting hot enough with my nozzle on this to crack the tar to make it safe enough where I can run it to the engine. So I know if I was running a 7.5 or a 12.5 horsepower Briggs, I would have no problem. I'd have more than enough heat to crack all the tars. I'm doing it with the 5 horsepower, so I know it'll do it with something a little bit larger. Now, the reason I brought this puppy out here is I want to kind of give you guys a quick explanation as to why FEMA makes a lot of tar. And this is from my first-hand experience, and pretty much from what I've read too. Notice that I'm coning down on this thing here. I'm reducing, okay? And of course I've got my reduction down here, and that's going to be determined by whatever size engine you're going to be using, etc., etc., okay? On this guy here, it's just a straight piece of pipe. That's one of the reasons why this guy will not crack tar properly, but that's not the main reason. One of the big reasons is, imagine you got fuel inside this thing. Just make believe this is the top of it, and you've ignited it and whatnot. You have a much slower air rate that's moving through this thing on those embers, because you got this big hole that's sucking the air down. You know, it's downdrafting into the top of the ember bed, and so you don't really get what you call a raised temperature on it like you need, versus when you have an invert system. And this is my actual nozzle here. I'm going to show you this, guys, here sitting like here, where you got a nozzle that's blasted into the ember bed, which is giving you the billow effect, which is also doing what? Raising your temperatures up to reach the proper temperatures to crack the tar with. So this is just what I've learned firsthand experience, and it took me a lot of tinkering with it. And I'm going to tell you right now, and I'm going to say this and make sure I'm clear on it, by no means, and I mean this, by no means am I the guru on gasifiers. There's a lot of people that know much, much more than I do about it, and everything that I'm learning and have learned has come from trial and error. But I wanted to pull this out here and just let you guys see this. Now what we're going to do is we're going to get on to showing you how to make the cone. Alright, this is the heart of the gasifier right here. That's why I started this part of the video first, as far as making the rim into a vessel and getting everything prepped up to put this fire cone into it. Because to me this is the hardest part of the job. Everything else is time consuming, but it's straightforward. So let's take a look at this. Let you guys get a decent look at it. This is 1/8 inch thick steel. And by the way, my original one is 1/16 of an inch. Pretty thin stuff, and I still didn't burn it out, all the running I've done on it. And I'll explain that a little bit later, why I think I got away with using a thinner metal. So I'm upgrading, so this also gave me a reason to make this part of the video for you guys, to let you see how I did this firsthand. Now, got the ring right here, and this, of course, it's 1 inch in height. This guy here is 5 inches in height. Now, it's somewhere along the line, I think in my last video or 1 or 2 videos back, when I was running the gasifier with the new setup, I think I was telling you guys, hey look, I don't see a lot of smoke in my wood hopper like a lot of people do. And this was totally by accident when I figured this out. What I realized was, let's set this guy right here where he's going to be going, was when that air nozzle sat down, like he protrudes an inch. I said it 2 inches, I think, in one of the videos. It's really an inch. When it sits down like an inch below on here, as long as this is covered up with wood, at least level with the top of this, flush with this, you'll see very little smoke inside of the hopper. You won't see smoke filling the hopper until this thing actually starts running out of fuel. That was just a good accident that I discovered. It wasn't on purpose, it was just something that I stumbled across. Now, what I'm going to do now is show you how I made this cone here. I actually went online, and there's a million zillion programs out there that you can do it online. They call them, some of them are called cone makers. Whether they intended it for machine shops or people doing little junior high school projects and whatnot, they give you the opportunity to go in there into the web page and punch in the numbers for the diameter, the height of your cone, etc., and then it prints out a paper sheet, and you cut out the template, which is what I've got right here. Of course, I didn't have to do that online. I was just able to make that as I went along. But I'm going to show you what this template looks like. This is the cone, actually. This is actually the stuff that I use to get my cones with. So I'm going to cut it where I've got it taped. We're going to look at the shape of it. And for people that work in machine shops and work with steel professionally, you already know what you're looking at. For the rest of you that are like me, that are clueless, there you go. It's almost the pattern of a windshield wiper on side of an automobile window. Now all I do is I take that guy right there, and I got a sheet of steel here. This is, once again, straightforward and simple. You take him, take you a marker, you trace it out, and then you go get you a quality jigsaw, okay? Don't get you some cheap, Walmart jigsaw that'll fall apart on you. Get you a decent one that's got some torque to it. Purchase some steel cutting blades with it, cut out your template. That's all you got to do. Now, that's part of it. You're probably going, well, how do you roll this thing? How do you get the shape to it? Now this, you're probably going to find hard to believe, but I promise you, I'm not pulling your leg. I'm going to show you how I shaped that cone. Matter of fact, here's another one for another project I was working on. And when you see how I did this, you're probably going to tell me that I'm pulling your leg, and I promise you I'm not. I'm going to show you the tools that I use to make that cone with. Thor's hammer, a pair of channel locks or vice grips, and a pipe. That's all I use to make that cone with. Basically what I did is I took this to work where I got a major, great big giant vise. I clamped him into the vise, and I took the piece of steel. We'll make believe this is the steel right here. And I took the vise and I clipped them on like this, and I rolled this thing around it, okay? And it was warped when I first did it. I had to go back and shape it, but I took it and I rolled it, and I used the hammer and tapped until I wound up with my shape. And then I fine-tuned it. Once I got the rough shape of it there, I fine-tuned it. But that's all I used. And basically, I just took the hammer and gently went around this thing. I took my time. It took me about an hour to do it. And just tapped on it, put the shape into it, would pull it off, look at it. I would examine it to make sure that I wasn't getting out of kilter with it. And once I finished it, I wound up with what you see right here. And it's probably not 100% true. It's probably a little bit off-shaped, and what I'll do is I'll go back with a hammer and round it off a little bit more before I stick it into the vessel here. But he's going to go in right here like this. The ring will be welded up on top of it, and of course this will weld to the bottom of the wood hopper. And that's it. That's the heart of this thing. Now there's one more thing also. The temperature in here gets pretty hot, and with this thin steel it would burn it right up. But I think I've mentioned this to you guys before about the Dixie Cup Experiment, where you can take an empty Dixie cup and light it on fire and it burns away. Then you can put water into it halfway and you light it and it stops at the water mark. And you can take that paper Dixie cup and you can boil water in it and not destroy the paper. Well, I'm getting the same protection with the steel here because the mixture I'm using, it's just right a tad below stainless steel, okay? And that's pretty high rated. As a matter of fact, the raw materials I'm using is sand, which is, I don't think it liquefies until you start getting past, I don't know, 3,200 degrees. I'm probably not correct on that. And the other mixtures I'm using into it, by the time I get everything mixed up, I'm probably good for about 2,900 degrees Fahrenheit. And by the time you pour this stuff in here and it sets, you may as well have made a damn engine block. Because what you've done is you've made a great big giant heat sink inside this thing to protect it. And that will protect it and keep it from burning up. Let me make sure this is still in the video here. Yes, it is. Just want to make sure you guys can see what I've got here. But when you fill this thing full of the mixture that I'm going to show you how to make, and that'll be the next step after this. Basically what you've done is you've got two things going on. First of all, you've made a hell of a heat sink, and you've also made a hell of an insulation sleeve around this thing, which is going to allow this thing to collect a lot of heat and really stabilize. That's also another factor why I think I'm getting good gas, because once this thing heats up and it's going, buddy, it's going, and I don't see any tars or anything, even though I'm pulling a minimal of air on this thing, because it is designed for a larger engine and I am running a slightly smaller engine, but it's still working for me. Now, when you put this thing together and you put the mixture in here and you let it harden, you know, you'll basically take this thing and either put it outside the sun, let it set for about 2 or 3 days, put it inside if you got an old vehicle or something where the sun can beat down on it, or even put it in your car, let the sun beat down on it and dry it out, or you can put it in your oven and run it for about 200 degrees for about 4 or 5 hours. It'll force all the water out of it, and you're not going to have any problems where you hear people talking about you never burn a fire on concrete because it'll explode. This will not do that. Because of the chemicals being used and the stuff that we're going to use, it's actually used for making castings for steel with. And I'll cover all that later on in the video. But basically, when you pour this stuff around here, you're not going to burn the steel out. You're never going to burn the steel out. And this steel here is going to last for a long time because the metal itself is never going to get cherry red. As in, if I just built a gasifier and said, okay, this is it. Like even on my little FEMA that I had, I guarantee you the bottom of that pipe, when it runs for a couple hours, it's red. It's not cherry red, but it's definitely glowing. And with this right here, you will not see it get red hot in here, ever. Not ever. Because you're going to have all this cement around here. It's going to act like a heat sink. So there you go. And what I'm going to do right now, guys, is I'm going to go ahead and finish this up. And like I said, all I'm going to do is weld him on here, and it's a done deal. And then the next step, we're actually going to put him in here and pour the casting in here and let this thing harden, and we're ready for the next step. Once again, this is the vessel that's made out of a trailer rim that's going to be used to house the fire cone with. And guys, it's completed and ready to go. Let's take a look at the fire cone one more time. I've got the top ring welded on it, so that's completed. And there's one more thing that I need to show you guys here. I'm going to flip it upside down. Of course, this is the reduction side of it right here. Notice that I've got 3 washers, 2 and the third one right over here. They're offset 120 degrees with each other. Now, you need to add something like this to it. It could be nails, it could be scrap steel, it can be washers like I did, and I'm going to show you why I did this. This is so when you set this guy in here and you pour your mixture around it to seal everything, those are like anchors. That's just a little bit of peace of mind that your cone isn't going to come loose and come out of here, which it won't anyhow, but basically once the stuff hardens, it's not coming apart. So be sure to add you something like this at the bottom of your fire cone, and be sure to raise them up from the bottom enough so that they don't hit your bolts, okay? Just be sure to have enough space on there so they miss everything. And that's it. So our next part of the video is going to be showing you guys how to mix up the mixture and how to set this thing in here properly. Alright, we're at the final step of finishing up this part of the gasifier, and this is what I also consider to be the heart of the gasifier. So the first thing we're going to do is take our fire cone, place them in the center of the vessel, make sure to line both holes up with each other, get them as close as you can get them. All that's left to do now is put our cement mixture in here and let it cure, and this part of the job is done. What we're going to use for that mixture is going to be common, just everyday plaster of Paris. You need a small 4-pound box of this. You also need a small bag of all-purpose sand. That's our magical ingredients. You'll need a small measuring cup, a bucket to mix the stuff in, and a tape measure, which I'll cover a little bit later in the video. You'll see why I've got that here. Now the good thing about this stuff is once this stuff is mixed together and poured into place, it's not going to come apart, it's not going to burn up or crack or explode or anything like that. The ratios that we're going to mix this stuff in is going to be 60-40. 40% plaster of Paris to 60% sand. The reason we're doing that is we're raising the temperature rating of this plaster of Paris up, which we could almost use it just like it is, to be honest with you. The maximum working temperature of plaster of Paris is right at 2200 degrees Fahrenheit or 1200 degrees Celsius. It doesn't melt. What would happen is it turns back to a dust, it breaks down. Sand, on the other hand, has a melting point of almost 3200 degrees Fahrenheit or 1700 degrees Celsius, somewhere in that neck of the woods. And when you mix these guys together in the proportions that I'm telling you, what you're going to wind up with is something that's going to be rated around 2800 degrees Fahrenheit. So in other words, it's not going to break down and cause you issues. So with this guy right here, I said 60-40 mixture. I'm probably going to go ahead and use 12 cups of sand to 8 cups of this right here. That way I'll have plenty of it mixed up. I'd rather have too much than not enough. I'm going to pause back out and start getting everything mixed up, and I'll let you see the mixture after I've got it ready. You don't want it soupy and you don't want it too dry. You want it where you can actually work with the stuff. So almost to the point of being able to pour it, but not quite. So I'll mix this by hand. Alright, we're mixed up, and this is what it looks like. I'm going to go add water to it, and I'll do that just a little bit at a time. And as I said, I want to get it to where it's just to the point where I can almost pour it, but not quite. Alright, that's about the consistency we're looking for. Let me show you. I can squeeze it through my hands so it's right at a putty mixture, but it's not where it'll pour. Okay, I'm going to bring our cone back over here. And we're not going to worry about being sloppy or anything being messy. That's not an issue there. We can clean up later. Just get around it. Work it in by hand. The most important thing is to keep everything centered up while you're doing this. So we're only going to pack this thing half full right now just to get it where it's stabilized, and then I'll take the tape measure and go around this thing and measure edge to edge and tilt the cone as needed to make sure that everything is lined up. I'm looking at the bottom of it too, where the hole is, where the reduction zone is. I can already see that it's pretty much staying where it needs to stay. Massage it down in there too. Make sure you get all the air bubbles or any kind of gaps that may be in there out of it. Right, I've got everything put in here, and this stuff will settle really quickly. It'll harden up probably in about 20 or 30 minutes and cure in about 2 days. What I'm going to do now is I'm going around it with the tape measure. And all I got to do is this number right here. Pull it over if it needs to be moved. Massage it back in place. And it's probably close enough where I've got it right here. Now, if for some reason that you have a little bit more of this stuff than you need on the surface right here when you go to weld it to the bottom of the wood hopper, the beauty of it is you can take your grinder and gently grind it down so that it'll be exactly with the height you need it, so it doesn't impede you when you go to weld it to the bottom of the wood hopper. But that's it, guys. And as you look at this now, this whole thing is the fire cone now, okay? This is the hole in it, and this is why I was saying the Dixie Cup effect, where when you fill a Dixie cup full of water, you cannot set it on fire. If you fill it half full of water, it'll burn down to the water line. Now you see why this steel is protected in here, because you got all this stuff in here. You may as well have it, like I said earlier, an engine block, because you have a hell of a lot of surface in here, not only to heat sink and protect the steel with, but also to store the heat in it. So once this thing reaches its temperature, this guy here is extremely stable. And what that means for you is a steady temperature on the gas, and if you're at the tar cracking temperature, then you've got it going on. Any comments, any questions, as always, feel free to send something to me in the blog. Send it to me psychically. Do it with a carrier pigeon. Just don't throw a rock through my window with a message, because if you do, I got to come get you. And this is Flash 001 USA. I'm going to go ahead and sign back off. As always, guys, any questions, seriously, just shoot me an email or shoot me something in the blog here. There you go. By the way, this stuff is already settling. See you guys on the next step. I've had quite a few people out there that have been in contact with me that are well into the build of their gasifier, and they've been asking me, hey, how are you setting up for the single air nozzle configuration? For those of you out there that have been asking me, I'm going to give you a quick explanation of this, and hopefully this will allow you to move forward. For the rest of you all out there, don't worry about it, because the next video is going to cover this in detail. Okay, let's get started. I've got a piece of pipe laid up here, so this isn't welded. This isn't even part of the setup, really, but this represents the side port ignition port. In other words, if you're in front of the gasifier, you'll see right above the grate shaker handle, I've got an access port there, and in some of the videos, you've actually seen me putting the torch to it and doing things like that, stuffing paper and lighting it, and then it gets sucked into it, and that's where it's happening. Also, you don't want this to protrude over, you just want it to come right to the edge, flush with the cone. Now, I don't use that side port ignition anymore. I do if I had the wood hopper slam full of fuel and say I had to shut down midway, I'll go ahead and ignite through the side, but the best way to ignite one is really from the top, especially just using biochar, because you can light one up very quickly and very evenly. But, you know, the side port does serve a purpose. Now, something to keep in mind too. You want to be sure this side port is dead center of two of these hooks, here and here. You don't want this guy being in the way of the chains or anything being in the way of anything. So keep your work tidy and leave everything spacious in there. Now I'm going to cover the air nozzle here for you guys. My air nozzle normally sets up right about here, and it protrudes 1 inch deep into the fire cone, okay? So you're seeing it. I'm trying to do this and hold the camera, so I'm not steady with this, but hopefully you can see what I've got here. Now, I told you guys before that I had a 1 inch flat ring that was welded to the top of the fire cone right here. Well, that's how deep my nozzle goes. It goes right here, and it stops right at the bottom of that flat ring right there. That's the main thing with mine, and that also helped, I'm sure it did, with keeping my hopper from filling up full of smoke. That was my accident that I discovered. Let's take a look at this nozzle. Okay. There it is. Now, on the inside of my wood hopper, I come in through the side of it like this. The air comes down, then I reduce down, and I come out here at a 1/2 inch. That's because I've got a 5 horsepower engine. If I was running a 7.5 or 12 horsepower engine, I probably would set up with a 3/4 inch nozzle, but that's the configuration I've got. I've also made some upgrades on this, and I'm making this thing absolutely user-friendly, because this is set up good right here. I love the way this is set up, but what I'm going to do is set this guy up so that I have a lock nut that's going to be right here, so when I screw him inside the hopper, I can lock him down so the thing can't swing back and forth. And I'm getting rid of all the reducers. I'll go with large pipe. I'll stop somewhere about here, and what I'm going to do is I'm going to make me a telescoping piece that comes out so that I put the nozzle in here. I can drop him down exactly where he wants to be and use another lock nut to tighten everything down so nothing can slip out. This way, guys, not if, but when the time comes to change out the nozzle, when I burn the end off of it, all I got to do is reach over here, unloosen it, pull the whole piece out, unscrew this, and put a new one in. It's real simple. And that's something I have stressed in past videos. KISS, keep it simple, stupid, because it will pay off. You know, originally I was going to go with air nozzles, and I actually did try them on the setup that I have now. And these were the nozzles that I made. I made them where they actually screwed in and screwed out, but I just didn't like them. To me, for my particular gasifier, this worked the best. But once again, like I said, for those of you all out there that haven't started on this, don't worry about it, because I will be making a video that goes into detail with this, as far as setting up the air nozzle, the ignition port, and everything else. That'll be the part of the next video.